Hi, Assalamualaikum and good morning. So I'm going to today I'm going to talk about my project that is Phenotypic and Genotypic assessment of Mutant Genotype, NMR152 and NMR151. So we start with research background. So basically Malaysia is currently placed among the lowest in Southeast Asia for rice self-sufficiency level. We hover around 60 to 70% ever since year 2000. And for a country that feeds on rice 2 to 3 times per day, this percentage shows just how much our country is depending on other rice producing country to fill up our SSL gap. So drought is one of the major problem in abiotic stress category that affect yield production. So what is it about drought that significantly affect rice yield? So when we go back to the nature of rice plant itself, the rice requires log water condition to grow well. So whenever rice plant is under water stress, the grain filling will also adversely affected. So researcher has suggested the cheapest and efficient way to go around drought is to use and cultivate drought-resistant rice variety. But the problem here is Malaysia is currently lack of drought-resistant variety, and also we are lack of drought study. Malaysian Nuclear Agency has successfully developed mutant line using gamma ray radiation on susceptible but high-yielding MR219 to produce drought-resistant and high-yielding NMR151 and NMR152. So this phenotyping and genotyping of drought rice mutant line will enable us to acquire important information on this complex strain. So we start with the research approach. First, we will prepare these 4 variety seedlings. The pre-germinated seeds will be transplanted into pots at the glass house 25 days after germination. So at 63 days, after 63 days after transplant, we will stop the irrigation for the drought treatment, while the regular treatment or control will have regular irrigation without pause. So for the drought treatment, we will re-irrigate when the tensiometer reading fell between -30 to -30 kPa. The soil surface can be seen cracking, and also when the leaf starts to roll and dry. So for the phenotypic assessment, each data of the parameter will be taken to be processed using ANOVA, that is the analysis of variance using Statistical Tool for Agriculture Research version star 2.0.1 to identify the significant difference between the variety and treatment. So this is the data that we take for yield, included these 3 main data: field grain, 1000 grain weight, and also grain weight per plant. While for morphological data, we take into leaf area, leaf length, leaf rolling score, and also leaf drying score. So for genotypic assessment, each DNA of these 4 variety, NMR151, NMR152, MR219, and Vandana, the Czech variety, we will extract DNA from each of these variety and test using our SSR marker linked to major drought yield, QTL, using PCR method. So this is the 5 qDTY, 5 major drought yield QTL that we test. That is qDTY₁.1, qDTY₁.2, qDTY₂.2, qDTY₃.1, and also qDTY₂.1. All these qDTY list of primer we can acquire from either a website called Grameen or a journal that has been published before. So we need to read through paper and see what are the previous study what are the price marker from previous study has used for this drought study. So the total of this SSR marker that we test that link to qDTY range from 32 to 40 rice marker. So after this genotypic assessment, this is the result that we get. For leaf area and leaf length, you can obviously see there's a difference between the drought and control. You can see for leaf area, for drought and control, for NMR151 and 152, there's not so much difference when we compare to MR219 for drought and control. And for leaf rolling, as we can see, this is the score for leaf rolling, 151, 152. MR219 scored the highest, which means it is tightly rolled, which shows that it is highly susceptible to drought, while NMR151 and 152 scored quite low for leaf rolling score, which shows that it has the ability to resist against drought stress. And for leaf drying score, we can see that NMR151 and 152 scored only 1, which is the lowest, and indicate a very high resistance against leaf drying in drought stress condition. And while for MR219, the parents of NMR151 and 152, it scores 7 as well. So it shows that it is very affected by the drought stress. So for yield grain, as we can see here, the grain yield for NMR151 and 152 for the control is high, which means it can still retain its yield despite being in water stress condition. While in 219, you can definitely see how it adversely affected, unlike its mutant line. And the check variety surprisingly also shows quite low reading as well. You can see from here for drought and control for M219, when in normal condition, 219 shows a very high yield. However, when we impose the drought stress, it drops to only 4% of field grain, while NMR152 from 84 in control, it dropped only to 47. It is still able to retain high yield. And same as well for NMR151, in control condition, it is 89% field grain, but when it's in drought, it's still able to retain half of the remaining yield. And we can see for 1000 grain weight, there's not so much of a difference from control and drought in 152 and in 151, and also in 151 and in 152. While in MR219, there's a huge difference as well shown. So that is for phenotypic. These 3 results is for phenotypic assessment. While genotypic assessment is this gel view. As we can see, all this is only some of the gel view. There is another 32 more, but I only able to make space for 5 gel here in the poster. So as we can see, 152 doesn't match with any of the band from the previously studied rice marker. So we can conclude, we can indicate here that there's a potential that the N152 and N151 there might be a new qTL that is responsible for drought that has not been studied in previous journal before. So for the discussion, mutant genotype 152 showed good performance in terms of yield and yield contribution traits such as grain yield per plant, spikelet fertility, and 1000 grain weight and in drought stress condition. And the mutant this is for phenotypic assessment, and based on genotypic assessment, the mutant rice genotype 152 were not amplified with any previously studied drought qTL. So this indicates that the drought yield tolerance trait in both mutant rice was controlled by other loci or other new qTL that we can and this opens up to new study in future lah. For conclusion, both mutant rice NMR152 and NMR151 are able to retain high yielding even in water stress condition when compared to the parent MR219, while the genotypic assessment may open up opportunities for further studies on exploration of new qTL in the mutant rice, and this might open the potential study for future R&D for drought tolerant rice in Malaysia. So that's all from me. Thank you for listening.